All right, so I'm going to jump into this video. I'm going to look at ratios and proportions as related to a geometry class. This video is going to be posted to my YouTube channel, so anybody might be able to see it. However, just as a little preface, this is a geometry concept. I'm going to refer to Caitlin, who is the daughter of a friend of mine who asked for help on this. So if it seems directed in that direction, that's where it is. But I'm hoping that anybody will find this helpful when looking at ratios and proportions, and specifically how that applies to geometry. So first of all, what is a ratio? I'm going to go back to algebra class. And let's suppose you have the fraction 15 tenths, and we need to simplify that fraction. If you recall that what we would do is we'd say, okay, is there a factor common to both 15 and to 10? So we could say that 15 is 5 times 3, 10 is 5 times 2, 5 divided by 5 is 1. We often say that they cancel out. Be careful, that cancel means that they're going to divide. Okay, so 5 divided by 5 is 1, and we have 3 to 2. So we're used to the concept, right? So if I reduce the fraction 15 over 10, we get 3 over 2. All right, we simplify the fraction. We often don't make that connection that that is actually a ratio. Okay, so 15 to 10, 15 is to 10 as 3 is to 2. What if I have 9 over 6? Okay, well, 9 is 3 times 3, and 6 is 3 times 2. 3 divided by 3 is 1. So again, we have the fraction 3 halves. 9/6 reduces to the ratio 3 to 2. Ratio is a comparison. So I'm looking at this book. So Caitlin, this is your book here that I'm looking at. And I'm looking at section 7.1, ratio. In this example, I'm going to kind of work this book, use this book as a guideline, again, to help Caitlin out here. But a baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including walks and so on. So you see that Joe Mauer for the Twins in 2006, he was at bat 521 times and he had 181 hits. So so 181 over 521, and that is the ratio of how many hits per at bats. We do that division, and you'll see that it divides out to approximately 0.347. And so there's my ratio of how often he gets a hit. Let's take that back. Let's suppose that you have a quarterback for a little known football team from, let's just say, the Bills, right? So you've got a quarterback who, in one game, throws the ball 25 times, completes the pass 15 times. So he's completed 15 out of 25 of his passes. So I'm going to simplify that. 15 is 5 times 3. 25 is 5 times 5. 5 divided by 5 is 1 3/5. So we can say that this little known quarterback, Josh Allen, has completed 3/5 of his passes. That doesn't mean he threw the ball 5 times and completed them 3 times, but that's the ratio. That's the rate at which That's the rate at which he completes passes. And we could say that that's that's 0.6. So he's got about a 60% pass completion rate. So you could say that I would say, okay, so let's suppose that Josh continues to complete his passes at the rate of 60%. Let's suppose in the next game he throws the ball 40 times. Well, what we can do is we can set up the proportion 15 over 25 is equal to x out of 40. This now is a proportion. 15 over 25 equals x over 40 is a proportion. The difference between a ratio and a proportion is a single fraction, 3 to 2, 3 to 2, 3 to 5. Okay. A ratio is a single fraction. What a proportion is when I take one fraction, 15 over 25, and set it equal to and compare it to another ratio. And when I say that those two ratios are equal, now I have a proportion. And I'm going to say that they are proportionate. So if overall Josh Allen completes 15 out of every 25 passes, which is a ratio of 3 to 5, Okay, and I like to simplify that first. It's going to make it easier to do the math in the future. 3 out of every 5 passes. Okay, so now he's going to pass the ball 40 times. How many completions would I expect? And to solve that, I'm going to cross multiply. 5 times x is 5x. 3 times 40 is 120. Okay, the reason that works, by the way, ready, Caitlin here, so 3/5 is equal to x over 40. Basically, what I can do is multiply both sides by 5. So that gives me, right, 5 divided by 5 is 1. So 3 is equal to 5x over 40. Now, if I multiply both sides by 40, the 40s cancel, and I have 5x equals 40 times 3, or 120. So cross multiplication is simply a faster way to plug through all of that algebra there. So now, if 5x equals 120, I'm going to divide both sides by 5, and x will equal 24. Now, what I can use that for is to say, well, if this little known quarterback, Josh Allen, completes 15 out of 25 passes, or 3 out of every 5 passes, out of 40 passes, I would expect him to complete 24. Okay, so there's a little work there with ratios and proportions. Okay, now let's move forward in your textbook here just a bit. Okay, and we're going to apply this to geometry. Okay, my pictures of your book here are as good as I have from this video. That's fine. But now you'll notice we've got this triangle. Okay, the ratio of the measures of the angles in a triangle is 3 to 4 to 5. Now what's different here, instead of having two values, 3 to 5. Okay, the ratio is 3 to 4 to 5. So we have this triangle. Okay, and there are three angles. Let's just call them angle A, angle B, and angle C. Okay, and looking at this problem, the ratio is 3 to 4 to 5. In other words, let's just back up and think about what that means for a moment. Suppose I have a triangle. Let's make this another triangle, and let's call this NEP. So I've got triangle NEP, and I say that this angle here is 20 degrees. This angle here is 90 degrees. So angle P, we should know, is going to be 70 degrees. If I say we've got angle N and we want to compare that to the measure of angle P and compare that to the measure of angle E, notice the ratio, I'm writing them with these colons here. So just like before, Josh Allen, right? 3 out of every 5 passes, we could write that ratio as 3 to 5, and we can use that colon. We don't normally do that if we've got two values that we're going to compare. When we get to 3, the fraction kind of breaks down and we use the colon. So angle N is 20 degrees, angle P is 70 degrees, and angle E is 90 degrees. Then I wonder if we can simplify those down. Can we divide anything out? We can actually divide 10 from each of those values. 20 divided by 10 is 2. 70 divided by 10 is 7. 90 divided by 10 is 9. So we can say that the ratio of the angles in triangle NEP are 2 to 7 to 9. Okay, so let's go back to this example 2. Okay, so if the angles are in the ratio of 3 to 4 to 5 for angle A, angle B, and angle C, we'll see how good my picture is. That means that I divided 3, 4, and 5 all by the same value, right? Kind of like in triangle NEP, I divided 20, 70, and 90 each by 10 to get down to the 2, 7, 9. We're working in the opposite direction. So that means we divided something by a value to get 3, something else by the same value to get 4, something else by that same value to get 5. So the other direction is I'm going to say that that first angle was 3x. The second angle was 4x. And the third angle was 5x. So what I divided, I don't know what I divided those three values by to get the 3, 4, 5. So I'm just going to call it x. I divided all three of those values by some value. Now 3x is the measure of angle A, 4x is the measure of angle B, and 5x is the measure of angle C. Okay, so we do know that since those are the three angles of a triangle, they should add up to 180 degrees. 3 plus 4 plus 5 is 12. 12x equals 180 degrees. So now I'm going to divide both sides by 12. 12 divided by 12 is 1. And we're going to get x equals 180 divided by 12, or 15. So x equals 15. What that tells me then, x is 15. So I'm going to take that 15, substitute that back in for the x's. 3 times 15 is 45. Let's use a comma there. 4 times 15 is 60. And 5 times 15 excuse me, is 75. So the three angles of that triangle were 45, 60, and 75 degrees. Okay, so I hope that that makes sense a little bit. Okay, let's move forward in our book here. Okay, so when I'm looking at this page here, solving the proportions, this is much like what I was talking about before. Okay, now you can see these two examples here, A and B. Let's just do a couple of here's 3A, 3B, and 3C. X over 4 equals 11 over negative 6. I'm going to cross multiply like I showed you before. Negative 6 times x is negative 6x. 4 times 11 is 44. And then now to solve for x, I'm going to divide both sides by negative 6. X is negative 44 over 6, or negative 22 over 3, because I can divide 44 and 6 each by 2. Okay. 2 times negative 22 is 44. 2 times 3 is 6, and the 2's divide out. Okay. If I've got something a little bit more complicated, like 3b, negative 4/7 is equal to 6 over 2y plus 5. It looks scarier, but I'm going to do the same thing. I'm going to cross multiply. Negative 4 times 2y plus 5, and 7 times 6. Negative 4 times 2y plus 5, and 7 times 6. Now, geometry's done. I'm going to use my algebra. Negative 8y minus 20 equals 42. I'm going to add 20 to both sides. So negative 8y is equal to 62. Divide by negative 8. And y is going to be negative 62 over 8. And negative 2 will divide into each of those. So I get negative 31/4. So we're getting fractions. Okay, double check my algebra, make sure I'm doing this okay. All right, but that's okay if I get the fractions. Okay, and so 3c would be similar to that. Let's move forward. Okay, all right, so that kind of covers that section. Let me do a couple of problems here. Let me see if I can find a good one. Let's do number 13 right here. Whoops, didn't mean to do that. Okay, so let's try number 13 right here. The ratio of the measures of the three sides of the triangle is 9 to 7 to 5. Okay, now those are the three sides of the triangle. So if I've got a triangle, one side is 9x, another side is 7x, and the third side is 5x. And the reason I know that is because since the three sides are in the ratio of 9 to 7 to 5, each side got divided by some value, but it's the same value for all three sides. So that's why I have the 9x, the 5x, and the 7x. If I add those together, 9x plus 5x plus 7x, that's going to give me a total of 21x. And we're told that the perimeter, right back over here, number 13, is 191.1 inches. So that's 191.1 inches. I don't have a calculator on this computer. That not one that's going to be good, I'm going to find easily. So 191.1 divided by 21, and I get an answer of x equals 9.1. That means that each side was divided by 9.1. So this side is 9 times 9.1. 9 times 9.1 is 81.9. This side here is 5 times the 9.1, so that's going to be 45.5. The 7x side is 7 times 9.1, so that's 63.7. And now to check myself, I'm going to add 81.9 plus 45.5 plus the 63.7 to confirm that, in fact, I do get 191. So those are the original three sides of the triangle. Okay. More problems that are similar to these, I'm going to suggest that you guys practice these problems. If Caitlin, you practice any of these, let me know how they go. Reach me either the contact information you have or through the YouTube channel, but that should help with that, I think. Okay, so let me pause this here and wish you good luck that you try. Again, I'm going to go back these problems on this page.